Alright. We're just going over the practice test today. You. Welcome. Anybody have any just general questions before we start looking at the practice test? It's the second test, so it's not as nerve-wracking, right? You kind of have an idea of how to play out, right? Are you going to put the Yes, I put them on this morning. So the formula sheet that I'll give you for test 2 is on Canvas if you want to be looking at it ahead of time. But I'll give you a printed one on test day, so you don't have to print it or anything. It's just there if you want to just be familiar with it. Okay. There you are there. I'll give you formulas and tables. Everything we've been using, so should be familiar. Okay. Think anything else? All right. So, you've probably seen it, but this is just a random version of the practice test I've got posted on Hawks. Okay, the one on Hawks you can take as many times as you want to, but you don't have to take it any. Okay, it's not worth any points. It's just a study tool, so it is there for you. You would like to use it. Okay, well, let's start looking at the practice test then. Okay. All right, so number 1, we're just calculating a standard score, and it spells it out. What's X, what's mu, what's sigma. So our formula we're using here, formula for a standard score, I'm gonna get a better color. X minus mu over sigma. Okay, so this one we're just plugging those numbers in. 94.8 minus 89.4 divided by 86.4. And just remember, if you're punching this all in your calculator all at once, you want to put parentheses around the top. Okay, so if you're going to type it all in at one time, you'll want parentheses there. Most of the time, I just do the top and then hit equal and then divide. But, so like I'm going to do 94.8 minus 89.4, hit equal, and then divided by 86.4. That's just a matter of preference. Okay, however you want to do it. It's round to 2 decimal places, so I got 0.0625, so that will round to 0.06 on that one. Questions on that one? You may have been having any calculator trouble or anything? All right, number 2, we start looking for areas. Number 2 says find the area under the standard normal curve to the left. I'm see if I can zoom in a little bit. To the left, negative 0.96. Okay. So since we're looking for the area to the left of that z value, okay, we just look it up. So we just look up negative 0.96 in our z tables or normal tables. So if we look up negative 0.96, remember down on the left side, we'll get the first 2 digits, so negative 0.9. Across the top, we'll get the last digit of 6. So there I got 0.1685. So area to the left, we just look it up. Look it up just like it's written. 3, similar, but this time we're looking for the area to the right of our z value. So we want the area to the right of negative 2.18. So for that one, the way I'm going to do it is I'm going to look up the opposite. which in this case would be positive 2.18. So look for positive 2.1. Last digit is 8. So I get 0.9854. Does that look right to you too? It's my first time working these, so if you see something weird, let me know. I do make mistakes. So. Bless you. Questions on those two so far? Yes, I'll give you these same ones. So, yeah, I'll give you these same tables and then a formula sheet. Number 4 says find the area under the standard normal curve between negative 0.62 and positive 1.47. So if we want the area between two z values, we look them both up just like they're written, and then we subtract the two areas that we find. So I'm going to look up negative 0.62 first. For negative 0.62, I get 0.2676. Positive 1.47. Let's see. Get 0.9292. And then we subtract. Which one will we put first? Yeah, the bigger one. Okay. Or you can just remember that our answer, since we're finding an area, it can't be negative. It can't be negative. So I'll do 0.9292 minus 0.2676. Got 0.6616. There, wait a minute. Yeah, okay. Yeah, that's right. Questions on that one? So between, see between, we're going to have to subtract. And we want to subtract the areas, not the z's. Okay. Number 5 is find the area under the standard normal curve to the left of 1.48 and to the right of 1.75. So really we just have two areas we're finding, and then we're going to add our answers together because we want the total. Okay. So for the first one, I'm going to look up 1.48, right, area to the left, you just look it up. If we do that, I get 0.9306. And then for the other one, we want the area to the right of it. So I'm going to look up the opposite. So I'm going to look up negative 1.75. Negative 1.75. 0.0401. And then we just add these two together. So final answer, I got 0.9707. Questions on finding any of those areas? Yes, our tables only give us area to the left. That's right, yeah. So that's why if we want the area to the right, we can look up the opposite and use the symmetry. That is correct. Others? Okay, number 6 here. Says the life of light bulbs is distributed normally. So if you see that, it's a good clue. We're going to use the z-table somewhere in there. Oh, this one throws us a little bit of a curve. It says the variance of the lifetime is 900, and the mean lifetime of a bulb is 580 hours. Find the probability of a bulb lasting for at most 625 hours. So we want the probability for at most 625. At most means less than or equal to. All right, so we need something, we got it that is distributed normally, so we need a z. So the thing we're going to change to z is the thing that we're wanting another probability about, the number we want another probability about. So the 625 number is the x that we want to change to a z. And in doing that, filling into our formula, x minus mu, 625 minus the mean, was 580. But this particular one had a little curve thrown in, because I just let Hawks give me random problems. It says the variance of the lifetime is 900. We don't want variance in our formula, we want standard deviation. So we need to take the square root of 900. That gives us 30. A little bit of curve on that one. Take our z, round it to 2 places. So 625 minus 580 divided by 30 gives me 1.5, so I'm going to call it 1.50. Let me move this standard deviation out of the way. Well, I thought I would. So now we need an area under the curve to get our probability. So we want less than or equal to, so which area is that going to be? Left, right, in between, or two tails? To the left, yeah, less than points to the left. Right? So we want the area to the left of the z value we got. So area to the left. .50. So we just look at 1.50. So 0.9332. Our probability. Questions on any piece of that one? That one had more steps to it. Nothing? Alrighty. Number 7, I'll try and see some maybe still trying to finish writing that up. So I'll read it to you while we're finishing that up. All right, trucks in a delivery fleet travel a mean of 110 miles per day with a standard deviation of 38 miles per day. The mileage per day is distributed normally. We're going to use Z somewhere. Find the probability that a truck drives between 132 and 159 miles per day. So we're distributed normally, so we want to use Z. And we want the probability a truck drives between 132 and 159 miles in a day. So on this one, we'll have two X's that we need to change to Z's. And then we'll find the area between those two Z's. So do our first Z formula here. So 132 minus the mean, which was 110. Divided by this one just gives us standard deviation this time of 38 miles per day. Now when I get a Z when we round to 2 decimal places of 0.58. For our second Z, got 159 minus the mean of 110 divided by the standard deviation of 38. When we round to 2 decimal places, I get 1.29. Anybody else try them and get those same numbers? Let me know if you get the same. You may get the same Z's. You did, okay. All right. Probably missed you nodding at me last time. All right. We get those two Z's. Now we find the two areas for area in between. We just look them both up just like they're written. So let's do 0.58 first. 0.58, I get 0.7190. 1.29, get 0.9015. And then I'm going to subtract. I'm just writing it that way to save room. Final answer, I get 0.1825. Once you get the two Z's, it just turns into an area between problem. So. Questions on that one? Hanging in there so far? That's the older stuff, so stuff you might be a little rustier on. So. Okay, number 8 says what value of Z divides the standard normal distribution so that half the area is on one side, half the area is on the other. The mean, which is what number on the standard normal distribution? I think I heard it. 0. Yep. It's 0 or 0.00 if you got it in the middle. Yeah. This is symmetric, right? 0 is the mean, so it's in the middle. Half the area is on one side, half the area is on the other. Number 9. Oh. This we just have to work around the little symbol there. All right. 9 says find the value of z, so be careful on these and don't get them mixed up with the ones we've already done. Our answer needs to be a value of z, such that the area that lies to the left of z is 0.07. So this is one of those inside-out problems. We've got a z that we're looking for, and the area to its left is 0.07. These are the ones where we look at the numbers inside the table, right, for our area, and then read to the outside of the table to get the z's, section 6.4. So we're trying to get as close as we can to 0.07 or 0.0700, yes. No, because it's a small area, and since it's to its left, we're gonna have it over there on the left. Yeah, it's the area. Yeah. Yeah, if that was the z, then it would be on the right. You're right. Okay, so we're looking for 0.0700. If it's not in there exactly, we get as close as we can get. I'm on the wrong page. Okay, let's see. I agree with that. So the closest area that I see is 0.0694. Close as we can get. And that gives us a z of negative 1.48. That's the closest. If it was in there exactly, we would just go with the z that was matched exactly, but since it was not quite in there exactly, we just get as close as we can get. Any questions on that one? Number 10, similar type of problem. This time we want the value of z such that 0.02 of the area lies to the right of z. So I've got an area here, 0.02 or 0.0200. How do we've got a couple ways we can do these. Yeah, we could subtract it from 1. All right, so if we subtract from 1, that'll tell us the area on the left. The area on the left would be 0.9800. 1 minus 0.02 is 0.98. Okay, so then you could look up 0.98 in the table. And if we look for 0.9800, closest one I'm seeing is 0.9798. Gives me a z value of 2.05. Okay. That works. Or, if you're good with doing it that way, do it that way. Okay. Or we could look in the table for 0.02. Just remember that whatever we find is going to be over here on the left side, so we have to change the sign. So if we look for 0.0200, we should, 0.0197 is as close as, nope, 0.0202 is as close as I can get. So that's negative 2.05. We just have to remember that's on the wrong side, so we need to change the sign. So positive 2.05. We get the same thing either method. That one's a little tricky because there's two areas that are really close. Questions on that one? Okay. Number 11. Suppose SAT mathematics scores are normally distributed with a mean of 518, standard deviation of 113. The university plans to recruit students whose scores are in the top 9%. What's the minimum score required for recruitment? So our answer needs to be an SAT math score, an X. So remember, the way we do these is first we find the Z that matches the information we're given, and then we've got the formula we can use to change that back to an X. So these are kind of those two-step problems. Right? So step one, we need to find a Z that matches the given information. So we want a Z value that's in the top 9%. So top 9%, what does that mean as far as area under the curve? We want 9% of the area to be which way? To the right. Yeah, percentile means to the left. Top percentage means to the right. So we want to find a Z value that has 9% or 0.09 of the area under the curve to its right. So this part you can do just like number 10. You can do it either method. Okay, I'm just going to look for 0.09 this time. Let's see, closest one I can find is 0.0901. That corresponds to a Z of negative 1.34. But I know the one I want's on the other side, so this Z is positive 1.34. You could also do 1 minus that, right, and look for 0.91 in the table, and you'll get positive 1.34. So there's my Z value. Now I need to change that to an SAT score. We're given the mean and the standard deviation. We've just found the Z. So remember, we have that formula. It says X is Z times sigma plus mu. That'll be on the formula sheet. So now we just plug in the 1.34 times the standard deviation of 113 plus the mean of 518. And it tells us to round to the nearest whole number. So 1.34 times 113 plus 518. I get 669.42. So nearest whole number is 669. Questions on that one? Probably the toughest part on that one is getting started, recognizing that our answer is something other than a Z, right? That our answer is going to be a data value. That was step one on the Z. So either you can look for an area of 0.09, and that'll give you negative 1.34, but we want the area to the right, so it'll be positive. Or you could do 1 minus that and look for that area, and you'll get positive 1. Anyway, it's just like we did on number 10. Same thing was on number 10. So questions on that one? It has a pretty good bit going on. Okay. 12. Get some confidence interval stuff. We've only got 17 on the practice test. So. Number 12 is a fast food restaurant executive wishes to know how many fast food meals adults eat each week. They want to construct a 99% confidence interval for the mean, and are assuming that the population standard deviation for the number of fast food meals consumed each week is 1.5. The study found that for a sample of 3,611 adults, the mean number of fast food meals consumed per week is 7.4. Construct the desired confidence interval around one decimal place. Okay. So we've kind of got 3 steps to go through on these. So step 1, we need our point estimate. So here we're dealing with means. So the point estimate we're looking for would be a sample mean. This one's pretty wordy, so you got a lot to filter through reading, but 7.4, yeah, so the mean of our sample data, 7.4. Okay, that's our point estimate. That's where we're going to start our interval. Second thing we need a margin of error. Okay, so margin of error, we've got several pieces to that. We've got 3 different margin of error formulas we need to be able to pick from. We have the one for sigma known situation, we have the one for sigma unknown situation, and then we have one for proportions. The proportions one, we can throw that out because we're dealing with means. Okay, so we have to think, are we in sigma known or sigma unknown? Sigma is population standard deviation. So it tells us they're assuming the population standard deviation is 1.5, so sigma is known here. So that'll tell us which margin of error formula to use. It's this one. It'll be labeled on the formula sheet. It's sigma known. So 2 of these things we've already got. Population standard deviation is 1.5. Sample size, I should have left myself a little more room here. Sample size is the big number, 3,611. So square root of 3,611. The only piece we're missing is critical Z. Okay, so how do we get a critical Z value? What do we look at in the problem first? Confidence. Yeah, so we want to be 99% confident. And for critical Z's, they're on our standard normal table. We're at the bottom, the little table at the bottom of table B. So if we want to be 99% confident, our critical Z is 2.575. Okay, so get our margin of error here, 2.575 times 1.5 divided by the square root of 3,611. Remember, you want to leave several decimal places. I'm going to go ahead and leave 6. Okay. I get 0.064277. And then I only got one more step. I could have organized better before I started this, but I only got one more step. Right? We take our point estimate and subtract the margin of error. Take our point estimate and add the margin of error. So when we subtract 7.4 minus 0.064277, we get 7.335 something. It says around to one decimal place, so 7.3. 3. And then 7.4 plus 0.064277. That one rounds to 7.5. All right, questions on any step on that one? We don't have a ton of these on there because they take a little bit longer. All right, so if you have a question, ask. Think anything? Good with finding the Z off that little table, and are you okay on knowing that that's the one we're going to use because it gives us the population standard deviation. And so we're going to use the one that has the population standard deviation in it, or that says sigma known. Okay. And I'll try to help out. I'll try to make it pretty clear which situation you're in. Okay. 13 says at the local college, study found that students had an average of 0.7 roommates per semester. A sample of 133 students was taken. What's the best point estimate for the average number of roommates per semester for all students at the local college? 0.7. This is really just a vocabulary question. Saying what's our best point estimate if we're dealing with means? The sample mean, our sample mean here is 0.7. It's that easy. Don't stress over it if I give you an easy problem. Questions on that one? Okay. 14 says the mean amount of money spent on lunch per week for a sample of 95 students is $19. If the margin of error for the population mean with 95% confidence interval is 1.90, construct a 95% confidence interval for the mean amount of money spent on lunch per week for all students. If you take these with kind of in the 3 steps order that we've been doing, it'll help on this one. Okay? This is the easy version of a confidence interval problem. Okay? Because step 1, we need the sample mean. What's our sample mean? Yeah, $19. Step 2, we need the margin of error. This one gives us margin of error. It's just wordy about it. It says if the margin of error for the population mean blah, 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 blah is 1.90. So E here is 1.90. Okay. So all we have to do is add 1 time and subtract 1 time. Okay. So 19 minus 1.9. It's money, so we can round to the nearest cent. $17.10. And then 19 plus 1.9 be $20.90. Try not to get in a rush, read carefully, because that one gives us the margin of error, so it's done most of the work for us. We just need to make the interval. Questions on that one? Okay. 15. Looking for a t-value. Okay, on Hawks, this one makes you pick the graph that matches the problem first. I'm not going to make you do that. I'm just going to ask you for the t-value. This one says, consider the value of t such that 0.05 of the area under the curve is to the right of t. Assuming the degrees of freedom equal 27, select the t-value from the t-table. So Here, just be careful on these because once you do the confidence intervals, you get used to having to subtract to get degrees of freedom. But this one already gives us degrees of freedom. We don't have to subtract. Degrees of freedom is 27. And then our area, 0.05, is it given to us in one tail or in two tails? One, because it just says to the right, okay? That's in one tail. Then we can go over to table C. 0.05 in one tail. That's the second column. 27 degrees of freedom. T value here, 1.703. Just reading the T table. What would be different if it said our area was to the left of T? It would be almost the same problem, except our T value would be negative, right? We're on the left side of the curve, our T values are negative. So. Questions on that one? You got it? Okay, sir. Yeah. Yes, here we are. No problem. Yeah, bless you. We're almost finished, so we're in no rush. Okay. I say that and somebody's like, I'm starving. Lunch. We'll be out. We'll be out. All right. Get that one? Almost. I'll come back for you if you want me to. All right. 16 says we have a random sample of 10 fields of corn with a mean yield of 22.5 bushels per acre and standard deviation of 5.84 bushels per acre. Determine the 99% confidence interval for the true mean yield. Assume the population is approximately normal. And this one's split up into two steps. Step 1 says find the critical value that should be used. That's asking us for not the margin of error. That's asking us for either the Z or the T that would be used in our margin of error formula. So which one are we going to have on this one? Is this one sigma known or sigma unknown? Unknown here, okay. If it doesn't say the population standard deviation is something, the standard deviation it gives you is going to be sample standard deviation S. Okay, I will help probably on the if I remember, I'll try to remember. On the test, I'll say and. So assume the population is approximately normal and sigma is unknown. To help. Okay. So here we want a critical T value. Okay. So what do we need? We need degrees of freedom, and we need area in the tails. So here our sample size is 10. The degrees of freedom would be 9. 10 minus 1. And then for the area in the tails, we look at the confidence level. Remember, confidence is area in the middle of the curve. So we'll have 1 minus 0.99, 0.01 in two tails. Okay, so if you want to figure out how much is in one tail, you can, but you don't have to. Now we can find our critical T. So 0.01 in two tails. Be careful, not 0.1, 0.01. Okay, so that's the last column, the fifth column. And then 9 degrees of freedom at 3.250. Yeah, for confidence interval, we always do 2 tails. Yeah. We'll do some stuff where we care about 1 tail later. But if you do 1 tail, you could divide that by 2 and get 0.005 in 1 tail, and that would be the same column. You don't have to. All right, so there's our critical T. Step 2, we just finish making the interval. So our sample mean 22.5 bushels. Okay. Margin of error, we already have our critical value, so 3.250 times our sample standard deviation, which is 5.84. That's S. And then divide by the square root of the sample size, so square root of 10. Let's see what we get there. So there I get 6.002003. Basically 6. It's not going to throw us off too much. Then step 3, do 22.5 minus 6.002003. Is around to 1 decimal place. On that one, I get 16.5. And then we add 22.5 plus 6.002003. That one, 28.5. I think I can post a copy of this on Canvas if you want to. Formatting might not be perfect, but it'll be pretty close. Questions on that one? Got one more to go. One more to go, last one. Okay. 17 says the FBI wants to determine the effectiveness of their 10 most wanted list. To do so, they need to find out the fraction of people who appear on the list that are actually caught. Step 1 says, suppose a sample of 306 suspected criminals is drawn. Of these people, 100 were captured. So that matches, so we don't have to worry about subtracting or anything there. Using the data, estimate the proportion of people who are caught after being on the 10 most wanted list. So we're looking for a proportion here, or in this case, we want the sample proportion. So we're counting the number of people that were caught. So we had 100 of those out of 306 in the sample. Okay, so that's acceptable. Or since we're going to have to punch it in our calculator here in a moment, we can write it as a decimal, and it says we can round to 3 decimal places. So if we change it to a decimal and round, that's 0.327. And then step 2 says make the interval. We want 85% confidence interval. So our margin of error for this one's easier to pick out because it's the only one with proportions. Critical Z times the square root of p hat times 1 minus p hat over n. So for our critical z, we want to be 85% confident. So we go to our little table on the bottom of table B again. So 1.44 for 85%. So 1.44 the square root 0.327 times 1 minus 0.327 divided by our sample size, which was 306. So there I get 0.161515. P hat was 0.327. We'll do p hat minus e, p hat plus e. Round to 3 decimal places, so 0.327 minus 0.161515. On the lower end, you get 0.165. On the upper end, when we add, you get 0.489. I'm sorry. You can see that better. Okay, let me check. Oh, okay, I probably did it like I wrote it. I wrote 0.377 and 0.327. I bet I punched in one. All right, let me adjust here. Double check. So 0.327 times 1 minus 0.327 divided by divided by 306. And then, yeah, it's going to be different. Square root of that times 1.44. Okay, so margin of error is not right. That's 0.038617. Is that what you got? Okay. All right, so then that changes our final answer here. So 0.327 minus 0.038617 gives me 0.288. And then if we add, get 0.366. Thank you. Did pretty good. I didn't mess up till the end. That we noticed. Any questions on that one? All right, that is it. If you didn't get on the sign-in sheet, try to get on there before you leave. Okay. Number 14, I sure will. I will see you Thursday.